Hello, welcome. I am live once again. Dan Schiffman here, live from the School for Poetic Computation in the West Village of New York City. Hopefully you can see me and hear me. I've got some music playing in the background, a little opening music. I don't have the opening trailer, promo video, whatever thing, which I will discuss a bit about in a moment. I want to make sure things seem to be working, so let me know in the chat. And it's about 1:15 p.m. on Eastern time on a Tuesday in New York City, a beautiful sunny day. But I'm here in a cave with some hot lights and some cameras pointed at me and a green wall behind me to talk to you about programming and coding and rainbows and unicorns and joyfulness and all sorts of things like that. So let's see, what's happening today? Who am I? Who are you? Where are we? Why are we here? All that sort of stuff. So I said before, my name is Dan. I do a weekly live stream around creative coding topics. I like to think that this is programming to make useless, playful experiments. And I hope you enjoy get something out of it. I hope you learn something, and I hope you contribute to a community and open source of people also being creative with code. And I hope you will consider being inclusive and bringing in people from everywhere into this world of creativity and coding. So if you want to sign up for stuff, you can subscribe to this channel. I don't know where you're watching this. There's probably a button somewhere, maybe like down here. I think there's a button over there where you can subscribe to this channel. You can stay tuned to my Twitter feed @Schiffman. And if you go to codingrainbow.com, the URL will likely change soon, which I will also talk about. But currently, if you go to codingrainbow.com, there you can sign up for an email list where I send out announcements when I'm going to do live streams, as well as if you feel so inclined, you can support my channel on Patreon and be subscribed to a Slack channel. Okay, so let's see, I think that's most of my introductory nonsense stuff. That I'm trying to think if I forgot anything. So let me talk a couple things. First about the time and topic of today. So the topic for today is... Oh, no, I need like applause. I don't have applause. I really got to work on my sound effects. That's the only sound effect I have. So it just goes with everything. I also have this. The topic for today is Markov chains. Is that it? Is our Markov chains? Is a Markov chain? This is the topic, Markov chains. But there's a lot that goes into that. There's some stuff about object-oriented programming in JavaScript. There's some stuff about looking at text in terms of something called an N-Gram. There's something about probability and using arrays and the random function. But ultimately, by the end of today, I will have built, I would like to, by the end of today, have built from scratch a Markov chain generator to generate text based on existing source texts. So I'm going to go through all the pieces of that and talk to you about what a Markov chain is and how you can program one and make some experiments. Now, the timing is fortuitous. Because I happen to need a new name for this channel. Now, previously I called this channel Coding Rainbow. It's a name that I adore and love for a number of reasons. Number one, it's sort of like a happy name. I love rainbows. It's an homage to Reading Rainbow, which is a 80s children's television show. And I think it's currently an app about reading and literacy, and they do wonderful, wonderful work. It sounds inclusive, meaning it's something for everybody. And it doesn't sound too serious, and it doesn't sound too technical. And so I'm looking to at the very least, keep the rainbow, taste the rainbow. Whoops, that's like a Skittles reference or something, I think. But I do need a new name, unfortunately, due to a trademark issue. But can't stop me and my rainbows. Are people still? Am I still in this live stream? I don't see anything going on in the chat. I think I still am there. Okay, so I do need a new name, and I've been taking suggestions. So first of all, if you have a suggestion, this is like the worst URL ever. If somebody could post this, if you guys are listening to me, please just post something in the chat, because I don't see any messages. Okay, no, we're here, we're saying. Okay, so you can go to this form, and you can submit a name suggestion. And since the topic is, unfortunately, I need somebody get me some rainbow sweaters or headbands or t-shirts or something that doesn't have green in it, because I got this green screen wall, so it doesn't work. But it's fortuitous timing because the algorithm that I want to look up today is something to generate text. And what better example to use to generate text than to generate a new name for this YouTube channel? By the way, just as a matter of reference, I've posted a couple tweets and I've gotten a lot of feedback. Right now, it seems what's leading is the joy of coding. Now, you might think, like, oh no, you're going to have the same problem because there is the joy of painting, a very famous PBS, also PBS show about painting starring Bob Ross, who is a well-known, wonderful person who made a wonderful show. And I like to think of him as an inspiration and a model for this thing that I'm doing on YouTube. There is also, however, the joy of cooking, which I kind of think of this more like I'm cooking. You got to get the ingredients and put everything together, and then bing, it comes out of the oven, and here's the little like Markov chain text generator. So, but from what I understand, speaking with getting some legal advice, is that the joy of phrase is too generic to be trademarked, and as long as I don't appropriate any symbols or logo or otherwise things too similar to an existing something, that I will likely be okay. Now, the issue with the joy of coding is that there's a conference out of Europe called Joy of Coding. There are a couple other like online platforms or YouTube streams that have that terminology in them. So I don't know. Oh, there's a problem with the mic. Okay. And I was just talking and talking. Fix the mic. Okay, I don't know what to do here. Let's try turning it off.
Your line first to wake her up?
Sure.
Okay. All right, Mercy, just say the line on the action cue, right? And then she'll wake up. Here we go, rolling, please. Here we go, settle, and...
Oh, sorry. I did the static thing again. Crap. Is it better? There's someone else on the mic channel. That's hilarious. I just want to know if it's fixed now. It is better. Yeah, okay. Sorry about that awful sound thing. Okay. So I'm back. Where did I last leave off, everybody? What was the last thing I said? Was I talking about the joy of coding? Okay, I cannot tell what's going on in the chat. You guys, the problem is when you just say yes or no, you're 10 or 15 seconds behind me and I don't know what you're referring to. So if you're answering a question of mine, unfortunately you have to say, yes, it sounds fine, or yes, you were talking about the joy of coding. Okay, yes, joy of coding. Okay, thank you. Okay, so that's a leading possibility for the name of this channel. And we'll see. I lost my train of thought. I was talking about Bob Ross and how I can't, et cetera, et cetera. So when I turned off the mic, you heard somebody else. Okay, I got it. Okay, so anyway, so so I have to figure out what I'm going to do about this. You know, right now I think this channel is just called Daniel Schiffman Programming or something like that. And I got some time. I don't need to worry about it. The point of what I'm doing is making these videos and hopefully creating a community of people who are watching these videos and interacting with each other about this sort of stuff. I used to have this other light here. Ah, there we go. So I don't know if I just turned on another light. I don't know if it's better or worse. Yeah, so some of you in the chat are asking me more questions about the trademark issues. I'm very happy to answer those questions. Static again? I'm seeing some of you post static in the chat, but I'm a little worried some of you are watching from earlier. So let me know. But I will I'll be happy to answer those. Mike is not having issues. Okay. This is too bad. This is quite a bit of fail here. What I'm going to do is I am going to change. I don't know how to change the mic channel. Anybody know how? Do we really think that's the issue? Yeah. Let me see what I can do here. One thing is I can do this. Is that a little better? Coding Rambo is a great suggestion. I can try to, I'm going to mute myself. Oh, bumping into something. Maybe it's just actually Alt F4 to change the mic channel. Can't hear anything, it's fine. Maybe this, the way the mic is on this particular, this is a different t-shirt than I usually wear. It is kind of scratching against, oh, hold on a second. Is it better if I hold it out without it being attached to my shirt? It's fine when I pick it up. So I wonder if there's an issue with the way that it is, yeah, it's intermittent, let's see. Where it's attached to my shirt, let's see. Hold on, I have an idea. Boy, this is riveting. Hold on. Let me put all this some music for you guys. As always, I always forget the this dot, this dot, this dot, this dot. I'm gonna do this dot, this dot. I'm gonna do this dot, this dot, this dot. I'm gonna do this dot, this dot. I'm gonna do dot, this dot, this dot, this dot, this dot song. This dot, this dot, this dot. Never forget this dot, this dot, this dot, this dot, this dot song. You guys are giving me great suggestions. This dot. Sound is low. This dot, this dot. Okay, I did turn it down. I'm going to do this dot. I did turn it down. Now I turned it back up. Okay, so how are things now? This was going so well. I had a whole plan. I'm over here looking to see if I can figure out how to change the channel. All right, everyone's saying it's fine. I'm gonna just keep going, and hopefully there won't be an issue. Okay, so oh yeah. So does this cause a problem? Is there static now? Because I do a lot of this. Wall sits. You know, wall sits are a good exercise. How long do you think I could do that for? It messed up again. Okay, just continue. Still issue. Okay, I'm gonna keep going for a little bit, and I'm gonna check in about the mic and see if I can reset things. It's static when I move. Oh, static, more static over here. Okay, getting a lot of mixed signals from the chat, but I have to keep going. Okay, so as you guys may be aware, I am teaching a course at ITP called Programming from A to Z. I have been using this fall, these weekly sessions, which will be on Tuesdays going forward for the time being, to cover a lot of topics here. And you can see these are the topics I've covered so far. And what I want to add to this list today is Markov chains. So in essence, yeah, I slapped my shirt and the noise came. It's a Faraday cage. Okay. I do sort of have a backup plan, but I guess I'm not gonna. Okay, so what I want to do, by the way, is I want to first do an introduction to week 5 video. So one thing that happens with these sessions is with the help of Mathieu, after the session is over, as you can see, there's a lot of like wasted time of trying to fix a microphone. After the session's over, I edit together some smaller videos that get posted in a playlist if you want to sort of follow the sequence of this course. Okay. I'm getting some. I'm going to try one more thing. Other idea. Let's see how bad it is with this shirt. Oh, yeah. This is the other shirt I was wearing today. So I was like, oh, I could just put it on. and then clip the microphone to this. This is going to be crazy. But let's just see if this even improves it. The nice thing about this shirt is it's like, clip it to the top of my laptop. Okay. Now, it's actually not as see-through as I thought it might be. I don't know if this makes this watching this video way too distracting. Okay, people seem to be enjoying the green shirt. Okay, I'm keying live using a piece of software called Wirecast, which does the keying for me. So I think actually, looking over on my preview monitor, it's not so bad. You know, I was using the neck collar, but that didn't seem to work when I tried that. Let's see, how's that? I can take this shirt back off. All right, boy. I hate these. This also solves the standing in front of the code problem. Okay, is this better now? Sound is much better now, except I don't know where you are. Okay, where we are in the. Much better on the collar. Awesome. I'm glad to hear this. Okay, so the first thing I'm going to do is talk about Markov chains in general. And I want to go to a couple things. N-Grams, Google. Oops. So where's the link to this? Sorry, Google N-Gram viewer. There we go. And rainbow, unicorn. Unicorn rainbows. Happy rainbows. Flying unicorns. No valid N-grams. I'm worried there's issues again with the sound. Okay. It's fine now. Okay. Okay, power through. Okay. So I'm sorry. I'm trying to think of some phrases that would be relevant to have in this. N-gram viewer. Rainbow. Sorry, I'm like so distracted by the sound problems, and I just keep like looking at the chat, trying to figure out if it's good or not. But I'm gonna power through for a little bit here. Okay. Happy code. Joyful code. Let's just do computer science. Creative code, creative writing. Okay, that sort of works. Okay, so this is one thing I want to have open. Sorry, I'm getting myself set up here. This is not my best. Let me look here for a couple other examples of things that were relevant. This is one that I want to look at, and this is one I want to look at. Look at also this ITP course generator. Okay, so And Chris Harrison. Oh, yeah. This is good to see. Sorry, everyone. As always, I always forget the this dot, this dot, this dot, this dot. I'm going to do this dot, this dot. I'm going to do this dot, this dot, this dot. I'm going to do this dot, this dot. I'm going to do dot, this dot. Okay, so I'm ready for, so what I want to do quickly is introduce this idea of a Markov chain and an N-gram and talk about the sort of overall content for this week. Then I am going to do a coding challenge where I program the Markov chain, and then I will wrap up with some exercise ideas. Okay? And so here we go, everybody. Okay. Sometimes I like to have these little musical bumpers. Hello, this is Programming from A to Z week 7. I don't know what week I'm on. Hold on a second. Let's look here. Session something or other. This is my Programming from A to Z playlists. Week 6. So it's week 7, just in case you're trying to figure out where we are. Week 1 was an introduction. Week 2 is regular expressions. Week 3 is libraries and APIs. Week 4 was looking at Node and Twitter bots. And week 5, text analysis and word counting. I forgot to do, so one of the things I try to do is I try to collect things that people are working on and show them at the beginning of the live stream. And somehow I've forgotten to do that yet again. So I'm really going to have to commit to doing that next week. Okay, so session 6, I'm going to call it. Okay. Hello, welcome to session 6 or week 6. I don't know, are you doing this every day, every week, every month? This could be year 6 for you if you wanted it to be. But this is Programming from A to Z. It's a set of tutorials, a kind of online course you could follow, all about programming and algorithms with text. Text, language, text, words, letters, all that sort of stuff. So today in this week's session, the focus will be about, the focus that I want to have is Markov chains. Whoa, what's a Markov chain? What's the deal? What's going on? So in the last session, I focused on something, the sort of topic of text analysis. So in last week, the idea was really exclusively about reading text in and analyzing it, counting how many times different words appear, trying to think about how you might do sentiment analysis. What happens when a computer program reads in text? I want to turn now towards what happens when a computer program writes its own text. And there, of course, are many, many ways that you could do this. In next week's session, I'm going to look at something called a context-free grammar. In other sessions, I hope to look at some machine learning techniques for generating text, as well as other just kind of creative ideas for ways to mix and match and have a program put together text as if it's writing it. Now, one thing I should say about this week's topic of Markov chains is it, by definition, requires a source text from which to generate text. So this is something you'll see in a lot of these algorithms for generating text. They also include a reading text component. So the Markov chain algorithm is based on this idea of an N-gram. Whoa. Edit! Mathieu's been very good at just like doing some jump cuts when I start to say things that don't make any sense. And I want to have a little like jump cut edit point there. I don't know when I clicked over, but I'll just leave it back over here. Now, a Markov chain is not something exclusive to the idea of text. And in fact, a Markov chain really just describes a sequence or a chain of states. Like, I am happy, I am sad, I am running, and I might typically on any given day be sad, and then I start running, and then I feel happy, and that's kind of my sequence. So with a Markov chain, looking at how certain states are sequenced and the probability of a given state following another state, we can evaluate sort of existing data, right? I can look and say like, oh, what's the weather like today? What's the weather like tomorrow? What's the weather like the next day over a year? And try to use that to either predict the new weather or to recreate a simulation of weather based on the sequence of states. So this is something I'll look at in more detail in the next video, but there's a piece of that, which is if I want to apply this idea of a Markov chain to text, what I want is for the characters or words of a piece of text to be states. For example, the state is I, the next state is am, the next state is feeling, the next state is like, dancing. So those are states, and whenever I say am, I usually say feeling, and then whenever I say feeling, I usually say like, but I might say the other day I'm feeling like eating some kale salad or something like that too. So this is like quite possibly the worst explanation of Markov chains ever on the internet, but you can skip to the next video where I'm sure it will make a lot of sense. But a piece of evaluating the statistical properties of characters and words, how they appear next to each other, is this idea of an N-gram. So this will also be a piece of the example that I build today of how do we look at a body of text and look at this idea of N-grams. Now, Google has this massive treasure trove repository of text, corpuses of text from 1800 all the way up until present day. And you can search for the frequency of certain N-grams. So these are what might be called bigrams, meaning two, computer science, creative code, creative writing. We could think of other ones like I am, and I could search for any of these bigrams and their frequency in text, and we can see that you can see first of all computer science started to appear more and more frequently starting in the 1960s. You can see a sort of more consistent amount of I am. You can see creative writing, creative code down here. So this is a way of looking at how, and we can look at trigrams, N-grams with an order, right? An order of 4, the order referring to the number. And you can do creative projects with this. So here's a great project by Chris Harrison called Web Trigrams, visualizing Google's trigram data. And we can see here, if we just look at this PDF, and I'm going to zoom into it so you can see here that in this project, Chris is visualizing all the words that tend to follow he, and then from there, all the words that tend to follow that. So I think these are some nice examples to look at, and you can kind of here imagine now, I have a, I am not, I was not, I do not, I can a. So you can sort of see the frequencies of these sequences, and if you can evaluate those frequencies, you can use those frequencies as probabilities from which to generate new text. So here's an example of a project made by Alison Parrish. The Interactive Telecommunications Program is a program at ITP. It's called IT. It's a program at ITP. It is ITP. It's where I teach. And we have courses every spring. And what Alison did is read all of the courses into a program, look at all the statistical properties of all the characters and words and how they appear next to each other, and use that to generate new courses. So I'm gonna let's find one that looks good. The Anthropologies of Virtual Design Workshop, MIDI and Cinematic Objects. This course, constraints of weekly sessions beyond exercises and inspire the possible. So this sounds great. I think I'll take that course. This is another example of a project called King James Programming, and these are posts generated by a Markov chain that has mixed several different input texts. The King James Bible, structured interpretation of computer programs, and some of Eric S. Raymond's writings run by Michael Walker. So you can see here, these are different things that are generated from that. Exercise 3.67 addresses why we want a local variable rather than a simple map as in the days of Herod the king. Okay, so there's a lot of possibilities for how you might use Markov chains for a creative output. And on the one hand, this is nothing new. This has been done and done and done and done again. This idea of reading in a source text, evaluate the probabilities on a character or word-based level, and I'll talk about that as I implement the code in the next video, and then text generating out of that. You could make a Twitter bot that generates text based on a Markov chain. So I think there's value, and hopefully you might enjoy exploring the idea, and you might even just take the examples that I provide and find your own source text in. But I think for you to think about what is the reason why you might do this, where might it fit into an existing project. I hear a walkie-talkie. And come up with some creative possibilities. So in the next video, I'm going to focus on the code, how to write the code to implement a Markov generator. I'm going to go through it entirely from scratch. And then I'm going to show you a few additional examples and then come back with some exercise ideas for things that you might want to try doing yourself after watching these videos. And then I hope you'll share them with me on Twitter @Schiffman, or you can subscribe to the Patreon to post your work in Slack as well. Okay, so I will see you guys in the next video. How is the sound on that, everybody? The thing is, I felt like that was kind of terrible, but I've been wanting, what I thought would be useful was to have introductory videos for each week's session. I need to go back and do other ones for like the earlier weeks. There are sessions that I didn't do yet, but whatever, that'll have to do for now. So, part of this is that I actually just did all this stuff this morning, ITP in a class, and it's like, in a way I should be like, this should be good because I practice it, now I have a sense of what to do, but I think that I lost my sort of spontaneous thing. Static made it a little bit bad, a bit glitchy on occasion. Is it really? I have another microphone. I'm tempted to just use the other microphone. Let's see how that goes. So, hold on, everybody. Okay. I'm going to try switching to a different microphone. I'm muting this one. So this is random, this is noise, Perlin noise that is. In the core random algorithm, the actual random algorithm itself, those numbers aren't related at all. You pick, like, I'm picking random numbers between 0 and 10. 9, 2, 7, 6, 1, 9, 4, 8, 9, 2, 1, 3. I pick 9 a lot apparently. But with Perlin noise, I might pick numbers like this. 2, 3, 4, 3, 4, 5, 6, 5, 4, 5, 6, 7, 5, 6, 7, 5, 6, 7, 8, 9, 8, 7, 6. Boy, this is like... Test. Okay, I'm now using a different microphone. And you guys can tell me, this is not theoretically not as nice a microphone, but hopefully it will work. Is everything okay? I hear sound is low. That's no problem. Oh, sound is low. Okay, sorry about that. Now I have a different microphone. I forgot that I turned the volume all the way down, so in case I didn't, some like bad, horrible thing happened. Okay, good, check, good, okay. A lot better. All right, so I'm going to use this other microphone now. We'll see if the static comes back. Hopefully that's going to do the trick. I'll put the Perlin noise song back on. So this is random. This is by F Looper. Perlin noise, that is. In the core, and I'm going to get set up algorithm, the actual random algorithm itself, those numbers aren't related at all. You pick, like, I'm picking random numbers between 0 and 10. 9, 2, 7. I'm going to get set up to do the first coding challenge. 4, 8, 9, 2, 1, 3. I pick 9 a lot apparently. But with Perlin noise, I might pick numbers like this. A to Z, week 5. 4, 5, 6, 5, 4, 5, 6, 7, 5, 6, 7, 5, 6, 7, 8, 9, say week 8, 6, even though it's the 7th week at ITP. Like Perlin noise performance art. I'm going to do my ridiculous thing. This is how I like to do it. I like to download P5JS every single time. And then I like to go to the empty example. I like to put it in here. And I like to say Markov chain. And now I want to open up terminal. 4, 3, 4, 5, 6, 5, 4, 5, 6, 7, 5, 6, 7, 5. Hurling noise, that is. Hurling noise. So this is hurling noise, that is. Hurling noise. This is hurling noise, that is. Hurling noise. So this is hurling noise, that is. Hurling noise. Hurling noise, that is. Hurling noise. So this is hurling noise, that is. Hurling noise. This is hurling noise, that is. Hurling noise. So this is hurling noise, that is. Hurling noise. Hurling noise, that is. Hurling noise. So this is hurling noise, that is. Hurling noise. This is hurling noise. Oh, I'm in the wrong. So this is hurling noise. Sorry, everybody. Hurling noise, that is. Hurling noise. This is hurling noise, that is. Hurling noise. This is hurling noise, that is. Hurling noise. So this is hurling noise, that is. Sorry, everybody. But with hurling noise, I might pick numbers like this. 2, 3, 4, 3, 4, 5, 6, 5, 4, 5, 6, 7, 5, 6, 7, 5, 2, 3, 4, 3, 4, 5, 6, 5, 4, 5. Okay. 7, 5, 6, here we go. 5. Boy, this is like hurling noise performance art. Okay, we are getting closer now to looking at Markov chains. Now I just need to open up the code. Let me run at it. Let me find the code. A to Z, week 6. Let's put this here. Let's put this here. Oh, Andrew, I see you in the chat. I didn't respond to your tweet yet, but I will. Thumbs up. I think that. So thank you for your help, and I will respond to you. Update is ready. Okay. Guess I'll install the update. I'm going to go here. I need the DOM library. And okay. Sorry for all this. This has really been quite slow. Where are we at now? 37 minutes. You guys are very patient. I probably lost a ton of viewers with all this wasted time. The audio is still good, I assume, yes? Okay. So, I'm ready. So this is the one thing that I'm trying to think about here is let's see, what am I thinking about here? What I have been doing typically, I'm looking for my whiteboard markers. I seem to have lost them. Oh, they're over here. I have typically thought of tried to do shorter videos, and many of them, as opposed to one longer one. And so I'm tempted to just do one video which shows you how to generate a list of all of the N-grams in a piece of text, and then follow that up with a video that does a Markov chain. So in that sense, it would be 2 parts. But I am also, and on the one hand, I'm also tempted to just do the whole thing because it's kind of a single project. And so I don't know what to do, but I think what I'm going to do is play it by ear. So I'm going to start, this is going to be completed in 2 parts. I'm going to discuss what a Markov chain is, what an N-gram is, and then I am going to implement the code for all of the above. Okay, sorry. If I'm a little bit quiet, I am a little quieter than it was before. I'm turning it up a tiny bit. Okay. So one thing I want to look up, and I know the camera just went off. I'm just want to go to this website. So I want to just reference here very briefly at the beginning this wonderful article by Victor Powell, which explains Markov chains visually through a set of animations. So I'm not going to use this in my video. I want to feel like I'm appropriating this content, but I'll put a link to it in the video's description, and I wanted to plug it because this helped me really think about and understand Markov chains in a nice way. Okay. So here we go. Now it's time. It's 2 o'clock. I have about an hour. So I have an hour to do this coding challenge. So the video in the end will be somewhere between 20 minutes and an hour, and we'll see. So here we go. And I'm going to cycle this other camera, and we're going to get started. So I'm trying to think of, I'll just leave it over here. Okay. Here we go. Hello, welcome to another coding challenge. This coding challenge is part of the Programming from A to Z course, which is all about programming with text. And so in this coding challenge, I am going to implement from scratch a Markov generator. So I need to talk about what this thing called an N-gram is. I need to talk about what a Markov chain is, and then how I use a Markov chain to generate text. So I'm going to do all of that and write the code from it in JavaScript from scratch in this video. One thing I want to just plug or reference is this wonderful article online by Victor Powell, Markov Chains Visually Explained. If you're looking for a supplemental resource to sort of think about Markov chains and how they work, this is really terrific, and I recommend you check it out. So I'm going to come over to the whiteboard first. No, I'm coming to empty space. It's all black. Hello, am I here? Yes, I'm here. I'm coming over to this whiteboard to talk about what a Markov chain is. So a Markov chain is a sequence of states. So what could those states be? Actually, in Victor Powell's article, he references, you could think of the states of a baby, playing, crying, eating, sleeping. And you could imagine, well, what's the sort of typical sequence? Does the baby first play, then the baby eats, then the baby sleeps, and then the baby cries. And that's kind of like a typical sequence, but sometimes it happens in other ways, right? We could kind of boil this all down and make the states, we could think of sort of this very like in a sort of cold mathematical sense, and the states could just be no. This will not do. I'll be right back. I think this will be edited out, me wandering around here. I'm looking for my eraser. I had this nice eraser that actually seems to work well, and I've completely lost it. Oh well, I don't know where it is. I'm going to have to just use something else. I have a paper towel. Where could it have gone? I'm losing my mind. Oh, thank you. You guys can hear me that I'm looking for an eraser. Look, a magical person from the other room brought me this eraser. This is amazing. Oh, look, it erased. Okay, thank you. All right, so now I have an eraser. Wow, this is amazing. I should always record with people in the next room listening in. Okay, let's try this. I could list states as simply letters. A, B. And the idea of a sequence means there's always a transition, a moment where the state goes from one state to another. So we could think about here that A could become B, or maybe A could stay as A, and B could become A, or B could stay as B. So if these are all the possible states and their transition to another state, and we said that there is a 50% chance of this happening, or a 50% chance of this happening, or a 50% chance of this happening, or a 50% chance of this happening, we could then create a sequence that matches these probabilities. I could say, start with A. I could flip a coin. Heads, it's A. I could flip a coin. Heads, it's A. I could flip a coin. Tails, it's B. I could flip a coin. Heads, it's A. I could flip a coin. Tails, it's B, right? So this idea here is that I am generating that sequence of states based on existing states and probability of an outcome after that. So this is used for a lot of different kinds of systems. You could imagine looking at financial data as a sequence of states, scientific data, weather patterns, predicting an earthquake based on some set of sensor readings and how they sequence, this sort of thing. So Markov chains are used in a variety of fields to analyze a sequence of states and also generate or predict outcomes based on that sequence. Now, what I want to use them for in this video is to think of text as a sequence of states. So let's say I wrote the sentence, this rainbow has a unicorn flying over it. So on the one hand, I could think of each character as a state. So how many possible states are there? Well, maybe there's 26 lowercase characters, 26 uppercase characters, different kinds of punctuation. And I could say the state is T followed by H, followed by I, followed by S, right? Followed by space, followed by R, followed by A, followed by I, right? So I could think of this as a sequence of states on the character level. I could also think of this as a sequence of states on the word level. Well, maybe there are however many tens of thousands or hundreds of thousands of words in the English language. Each one of those could be a state. The state is this, followed by rainbow, followed by has, followed by a. Now, in a small corpus, in a small source text, I won't see that many possibilities. The word rainbow is the only word that ever follows this. But if I were to evaluate a large body of text, I would see this followed by rainbow, followed by unicorn, followed by this dot for JavaScript programming, right? And I might be able to say, you know what comes after this a lot? This rainbow. And I could start to adjust these probabilities based on an existing source text. And this is the idea. If we can read in a text, look at what kinds of characters come after a given character and how frequently I can start to generate a text based on those probabilities. But there's one more element to this. Right now I'm talking about just each state being a single character or each state being a single word. But there is a concept. I don't know why I'm coming over here. I thought I had something for this. Don't have anything for this over here. There is a concept known as an N-gram. An N-gram being a contiguous sequence of characters or words, a continuous sequence of text. And an N-gram has something associated with it called an order. We could say bigrams being n-grams of 2, or trigrams being n-grams of 3. And when I say that, I mean let's look at all of the trigrams in this particular sentence, this rainbow has a unicorn. Here's a trigram, T-H-I. The next trigram is H-I-S. The next trigram is I-S space. I'm doing an underscore for space. The next trigram is S_R. So what I could do is actually consider the states not to be single characters, not to be single words, but bigrams or trigrams are n-grams with an order of 4 or 5 or 6. In other words, I could say if the state is THI, what are all the possible characters that could follow that? So what I want to do is read in a text, make a list of all of the n-grams in that text. Let's just say an order of 3 to start with. All of the trigrams in that text. And then for each trigram, make a list of all the possible outcomes. Then I have a statistical model of how the text is put together on a character level, and I can use that statistical model to generate new text with those same probabilities and properties. So this is what I'm going to start to build right now. And I'm going to build it on the character level, and maybe I'll do a second video where I adjust it to work on the word level. Okay. Here we go. This can be an edit point for Mathieu. I just want to make sure everything's working okay, because I had sound issues before, and I kind of went on for a while. It was a unicorn. Dan, writing off view. Oh, did I write stuff out of the view of the camera? How bad was it? Sound was great. Everything was great. I'm taking a pause here, Mathieu. Thank you for editing this together to see if there are any questions. Andrew Kim writes, I always thought the grams were words as a whole. So yes, it's typically, like if you look at the Google Book View or N-grams, it's typically thought of that way. But I'm going to do it on a character level, which I think is a little bit more useful. Okay, so I'm going to pretend I'm walking back into the other camera and keep going. Okay, so let me Do that again, and I'm going to keep going. Thank you, Sasquatch, for saying that was a great explanation of the concept. I feel like I should just throw away that first video. This was much better. Okay. Okay, so whoops, I stepped on something. So let's start programming this. So I have a completely empty P5 sketch, and I want to start with putting some text at the top, where I will say this rainbow has a unicorn flying over it. And I don't need draw, and I don't need a canvas. So the first thing I want to do is simply make a list of all of the trigrams. So I'm going to include a variable called order, and I'm going to say order equals 3. And that's something we could adjust if later I want it to be bigrams or n-grams of order 5, that sort of thing. And I'm going to just loop through the text. So what I first want to do is just look at every single character, one at a time. Text.length, I++. And then what I want to do is pull out the trigram. So I can see plainly that the first trigram is thi. And the way that I can pull out a piece of a string from another string is with the function substring. So I'm going to say var gram equals text.substring, and I could say this, right? 0, 3 would give me thi. Now you might be wondering, the index values are this, 0, 1, 2, 3. Why doesn't 0, 3 give me this? An important thing to remember is substring, the first index is included, the last index is excluded. So actually 0, 3 gives me thi, 3 characters from 0, 1, and 2. Which is exactly what I want. But I don't actually want to say 0, 3. What I want to say is I and I plus 3. Because what I want as I'm looping is thi, then his, then is space, then s space r, that sort of thing. And I can make a variable called n-grams, and I can make it an array. And then I can say n-grams.push gram, and at the end here, I can say console.log n-grams. So let's run this code, and this is just a simple piece of code to give me a list of every trigram in this particular piece of text. And we can see, there it is. I can make this a little bit bigger for you, in case you can't see that. And you can see there are all those n-grams. Now, there's a little bit of a problem. Notice at the end, t period and just period. So those aren't trigrams. Those are just 2 characters, then 1 character. That's because I let it loop all the way to the end. And I actually want to say minus order plus 1, I think. Or I could just say less than or equal to text.length minus order. So that should give me r space I, space it, and it period. So now we can see there's the list. Now here's the thing. This is not a unique list of only of the trigrams. This is just a list of every single trigram. But ultimately, what I'm going to want to do, and I'm going to come back over here, is what I want to build is a big table. I want to build a table where I have, trigram ABC points at all the possible things that could come after it, and trigram FEG, all of the trigrams. That's not the alphabet. EFG, ABC, and I forgot D. ABC, D, E, F. All the. I don't know. Now I'm putting numbers here. I kind of lost my train of thought there. But I want to build. I want to build this table. So what I need to do is pair a trigram, an n-gram, with an array. And guess what? Remember when I made some video about word counting where you said, hey, let's pair a string with a count? And I used the JavaScript object as a collection of name-value pairs? We can do exactly this here, only the name, the fields, the properties of that JavaScript object are the n-grams, and instead of having a count with how many times they appear, I want to have an array with all the possible outcomes after that. So let me come back over here and start implementing that in the code. Okay, so first, instead of having an array of n-grams, I want to have a object. Yes, an object. And when I find a gram, I want to ask, does that gram already exist? Right? If that gram already exists, well, let's just do a count for right now. I could say, increase its count. Otherwise, Otherwise, set its count equal to 1, right? If it doesn't exist, set its count equal to 1. If it already exists, and you know what? This is kind of silly of me, but I feel like it's a little bit more readable if I write it this way, right? Because if it doesn't exist, set its count to 1. If it does exist, increase its count. So let's go back over here and see what do I get. Now, unfortunately, the text that I wrote, everything only appears once. So what I'm going to do is I'm going to artificially create some text where there's a bunch of things that appear multiple times. So let's try to, maybe you guys, there's some people watching the live chat can suggest things for me to write. So I'll write, the theremin is theirs. Okay? Yes, it is. This is a theremin. I don't know, that's like the weirdest sentence. But now, at the very least, if I run this again, you can see that certain trigrams appear many times. Like space I is appears 3 times, space TH appears 4 times. This is in alphabetical order. THE appears 4 times. S comma space appears twice. So we're seeing the frequency of these trigrams, these collections of 3 characters. So all I've done so far is make a nice little table which counts how many times the n-grams appear. But I want more. What I want to do is what I've got over here. I want to have a list of things that come after. And what do I mean by after is whenever this trigram appears, what's the character that appears after it? So if I come back over here, what I want to do is when I have found a new gram that I haven't seen before, make an array. The key for this, the value for this key in the object is an array. And then, of course, what I want to do is put something in that array, like the next character. And what is the next character? The next character is I plus 3. Push text car at I plus 3, right? Because I'm looking at this sequence of 3 characters, and the one that appears right after it is 3 later. And then, of course, if I have already found it, I don't need to make a new array. I just need to push that character. You can see there's some redundancy here, so let's clean up that redundancy. I can actually just say, if it's not there, make an array, and then always push that other character in it. So let's see what happens now if we look at what I'm storing in data. OK, look at this. Now, look at this. If I go down to THE and look at that, we can see, look, what are the possible things? So after THE, I could have a space, I could have an R, or I could have an I. And look at this, R appears twice. Now in some cases, when I'm programming, I'll see that R appearing twice and think, this is not so good. There's some redundancy here. I should just have R in a count of 2. We did this for word counting, right? We didn't want a list of all the words with the words in there multiple times. We wanted a list of the unique words and their count. But there's something going on here, which is that if this is my set of possibilities, space, R, I, or R, what if I said to you, pick one random possibility? Pick space, or R, or I, or R. Well, R is actually going to be picked 50% of the time. I only 25% of the time, and space only 25% of the time. The mere fact that we are duplicating the possibilities over and over again into the array, the more times they appear, the more likely they'll get picked when we generate text. So this is actually a side effect of having this redundancy that we actually want. So this is really useful. You could kind of say like, oh, this is inefficient, it's wasting memory, and I could store a number, and I could do some other kind of math, and all of that is true. And I encourage you to go forward and go forth and make a more compact version of this. But the ease of doing it this way, and come on, these are individual characters. Think about how your computer stores images of millions of pixels and videos. It's not that much of a memory overload. There's a question of scalability and how much data, et cetera, et cetera. But I think we don't need to worry about that right now. This is going to work beautifully. So let's look at this. I'm going to come back over here right now. And we are getting there. We have now space R. We have this list of trigrams and the letters that come after it. So what I'm going to do now is I am going to build into this. I'm going to add some stuff to this example. I'm going to create a button because what I want to do is have a button equals create button. And I'm using some code from the P5 DOM library, which allows me to quickly mock up some interface elements. And I'll call that generate. And then I'm going to say button.mouse pressed. And I'm going to say Markov it. So now I'm going to run the Markov. Now I need to write an algorithm to generate the text. And then we will say create P, the result. So right now, of course, let's just make sure this works. Right now, all I'm getting is the result. But ultimately, of course, what I need to do is right here, I'm going to write an algorithm that generates text based on the input. So we have a question. I mean, I have a question. You might have a question. How do we start? Right? This is the text. The theremin is theirs, OK? Yes, it is. Is my grammar OK there? I don't know. All of a sudden, I'm getting worried. But what do we start with? Now, this is a question that I will think about and talk about and maybe think in later, either later in this video or in the next video, because there's lots of different kinds of ways you might use a Markov chain, or using a Markov chain to generate short phrases or long bodies of text, or how are you reading in the text? Are you reading in a bunch of short phrases? Are you on the character level, the word level? But for right now, the simplest thing I'm going to do is start just with whatever the first three letters, whatever the first n-gram is of this text. So I'm going to go down here and say var current gram equals text substring 0, order, right? I want it from 0 to 3. That's what I want to start with. Now, what I want to look is say, what are the possibilities? The possibilities are n-grams, current gram, right? I want to look up what are the possible next characters based on what the current gram is. And that's what I just built this whole object to have. It has an array. So now I can say next equals, I want to pick a random element from that array. And guess what? P5, since I'm using the P5 library, it has a function called random. If I pass it an array, it gives me a random element from that array. So it's going to pick that random function. If it's this array, it's going to pick space R, I, or R, randomly one of those. OK, so once I have that, I can say the result is the current gram plus next. And I can create P result. So let's just look at this and do some generation. There, the, space, there. Give me an I, they, THI. So you can see I got R about 50% of the time. I got space 25% of the time, and I 25% of the time. Not exactly, of course, because this is probability based. And I could run this again. We could see R is going to come up more often, but I'm getting all of these possibilities. And I'm standing in front of this, so I'm going to move this over a little bit. OK, so now, I only did it once, though. The point is, once I've done this, now I want to look at the gram HER and see what are the possibilities next and generate a new character. Then I want to look at ER and whatever I pick there. And then what are the possibilities after that? So I want to do this. I want to iterate and continue to do this over and over again. So when do I stop doing this? That's another question that has a bunch of different possible answers. But I'm going to say right now, basically, what I want to do is let's just say I'm going to do this 10 times. I'm going to write a little loop to do this 10 times. And what I'm going to do, a result needs to be kind of a variable that's declared, right? The things that I need to do before the loop are pick the starting gram, n-gram, and start that result, which is that starting n-gram. Then I will only have to add the next character. So what I'm doing is saying 10 times, give me the possibilities, then pick a random one, and then add it to the result. But then I need to go and look at the next current gram. And what is the next trigram? It's the last three characters of whatever I've generated so far. So I can say current gram equals text.substring, text.length -3, text.length. Oh, not text, the current result, right? What I've generated so far. Right? Yes. Excuse me, sorry. Text is the original string, which plays no role anymore. The original string was simply used to build the table of n-grams and their possible next states. So now, and I could just to make this a little bit shorter, just so you can kind of see it a little more easily, I'm just going to write it like this. So what I'm getting, right, is that I want the next gram to be the last 3 characters of the text. So now if we do this, whoops, I have an error in line 30 plus result, result plus equals next. There, I don't know what was going on there. The theremin, there's, okay? There, theremin is I. So we can see here instantly how I've got these sequences of 10 characters that have the quality of the source text, but they're randomly new. This is going to be like an edit point because I'm trying to think of what to do next. So I think okay. I'm trying to think here. What time is it, by the way? 2:22. I'm doing well on time. Okay, so what I want to do next is maybe bring in some different text into this. So let me actually get that prepared. Let's go to Unicorn Wikipedia. And I'm just going to like grab some text. Just have it like prepared. So Machia, this part doesn't need to be in the video. And I can copy paste this in. Okay, so what I'm going to do is grab that text, and then what I'll do also is, look, I will, I'm also going to go and do the name generation thing. Boy, it's 80 degrees. I finally got to the point where it was always cool in here, and now it's like super hot again. Let me just do this. Okay. Yasu to Greece. Tikanye. Did I say that right? Okay. Oops, I'm on Twitter for no reason. I lost. Here we go. Okay. So I'm going to make an edit point. I'm going to make an edit point to come in and paste new text in. So I'm reading the chat. You guys are talking to each other, not me. Okay. Let's grab some different text and see what happens. So I've got already here pre-made like text about unicorns from Wikipedia because I don't have any other ideas. And I'm going to comment this out and just say var txt equals and paste this text in. And keep the order at 3. Let's allow it to generate 50 characters in length, and let's refresh and hit generate. We can see, what do we get? The erroneously beast with the unicorn is of nature. The younce of narwhal with a symbol of the unicorn wa. And you can see it just sort of cuts off. I can let me actually let it go for longer if it can, as well as let's make the order 6. Oh, okay, so we got an error. So this is quite likely to happen. So first of all, what? There's all these crazy numbers in there. So I can tell you what the error is, which is that if this possibility is this is somehow undefined, then this random function won't know how to pick something from an array because there's no array, and the random function actually is meant to give you a random number. So that's why I suddenly got a random number in there. So one thing I can do to just add a little protection here is say if not possibilities, meaning if it's not defined, then break. And so this is a way of having the, this can be edited out also. This is a way of having the Markov chain end if it has no more possibilities. So let's do this. And I think the issue that I've got here is, you know what I did actually? I hard-coded in the number 3. So this should really be order, right? Because I've changed the order, meaning the length of the n-gram, so I can't just have use the number 3 anymore down there. That's a big problem. Okay, so now let me run this. Generate, oops. Hold on, did I save this? Hold on. This might need to get edited out as well. Oh, it's still doing 3. So where else do I have hard-coded 3? Oh, I have hard-coded 3 here. This makes this easier for Mathieu to edit. Oops, I also put the hard-coded number 3 in up here. Oh, this is awful. You guys in the chat are already telling me this. So now I can hit refresh. It's not over yet. Where else? Oh, look, I have it over here. I think this is going to work now. Yeah, there we go. So you can see here, I'm getting, with an order of 6, I'm going to get less nonsense, right? Because it needs to have sequences of 6 characters that actually appear in the original source text. And so, but if I were to give it something like an order of 2, we can see we're going to get a lot more nonsense, like the in its growl, the symbol, wicken so depirable, alar wikumimali, ali a inti by the unikinyao. Okay, so this is my favorite word right here. Setententiutimili. Anybody, I got it, that's the name for this channel. Setententiunimili coding. Rainbow. Okay, so you can see that there's a lot to play with here. So on the one hand, this video is over. And in fact, it is over. I'm going to, in the next video, look at a few different scenarios of using a Markov chain to generate long text versus short text. And in the next video, what I'm going to do is try to use a Markov chain to generate a new name for this YouTube channel. So hopefully I'm going to publish the code with this, obviously. It'll be linked in the video's description. And I look forward to seeing what kind of source text you might use that's different than the source text I'm using, and what kind of, how you might present the outcome. Are you kind of appropriating another design to make it appear as if it's generating news headlines? Or are you recreating a Twitter bot that generates text using a Markov chain? There's a lot of possibilities there, and I hope you will share with me your results. Thanks for watching. OK. So I chickened out of just letting this video go and go and go and go and go. I'm looking at the time, 2:30. Got another half an hour here. So what I want to do, I'm trying to decide if I want to pull dynamically from this Google Sheet. So I don't know why I have a separate. So this is currently a set of names. This is making sure there's nothing too awful in here. Okay. So this is currently, by the way, if you're somebody in the chat can post a link to this Google form, which I posted a while ago. And if people want to keep submitting name ideas, please do so. Either way, I kind of feel like I want to have some sort of contest, maybe. Of course, I'm probably just going to name the channel The Joy of Coding because I can't come up with anything else. But if there was a different name that I picked that somebody suggested, I would love to give out a prize for that. I don't know what the prize would be. Free programming books, some stickers and a T-shirt. I don't know. Let me look here, and I think what I should do is just load this from a file. Because I think all the code that I'm going to add to load it from, oh, why chicken out? Let's load it from a Google spreadsheet. No, let's load it from a file. Okay. So what I'm going to do is I'm going to copy this. I'm going to create a new file. And I'm going to call it names.txt. And I'm going to paste. Whoa, it pasted a lot of extra nonsense. Oh my goodness, seriously? Oh no, it's just, or is it just that I have my preference set to let myself scroll below? Right? Hold on everybody. I'm gonna just paste these. There we go. No. Okay. So now I have a list of names. So what I'm going to do now is, let me make a new sketch just to, Markov chain dash names. And let me go here, back, Markov chain names, and so, and let me close all these, and let me go here. So what I want now is to load in, okay. Okay, I think I know what I'm going to do, and I'm just going to get started. Let me cycle the cameras. Oops, I left the other one off for no good reason. Okay. How would this code, Alon in the chat asked, how would this code behave if instead of letters it would generate every n-gram another n-gram? That's interesting. I don't actually have an answer for that. It's an interesting question, and I would be happy to explore that. But I would say give that a try and see what happens and let me know. Okay. So what I'm going to do now is pull from a list. So I'm going to, let me move this file into here. Coding paradise. I kind of like that. Coding balloon, the joy of code, joy of coding. But I miss any really good names? People are probably adding some. Let me just really quickly check to see if there's any new names I should make sure to add in. Oh, there's a bunch. And I'm going to come down here. And I think maybe I'll take out Barbara and Paul. I don't mind hi so much. I think it's going to cause a problem because it's going to be too short. Okay. Okay, so here we go. I'm in this next video. Okay. So I think these will be like a coding challenge, 0.1, 0.2, 0.3 kind of thing. So no, I can't think of a better way to do it. Okay. Hello. In this video, I'm going to see if I can come up with a new name for this YouTube channel because I need a new name. And what I'm going to do is I'm going to generate one using an algorithm called the Markov chain. Now, if you watched the previous video, then I spent a lot of time talking about what a Markov chain is and building the code for a Markov chain from scratch. One thing I didn't do, however, which this video will focus on, is how to use a Markov chain to generate a short phrase. So in this sense, what I'm going to feed into the Markov chain is many, many examples of that short phrase. So you could use city names or character names or thesis title ideas or course title ideas. I'm thinking of like school stuff because that's where my brain is at. But YouTube channel names. So here are a bunch of YouTube channel names that came in suggested from the viewers through a Google form. Now I could actually connect to the Google form directly, and I have an example that shows you how to do that. But I think for right now, for simplicity's sake, this is just in a text file called names.txt. So I'm going to go to the Markov chain code. No longer do I want to have the hard-coded text about the unicorn or the theremin. Instead, what I want to do is I'm going to make a variable called names. I'm going to add the preload function. So in P5, the preload function is a function where I can preload data files like images, sounds, and other kinds of data files. And I'm going to say names equals load strings names.txt. So if I do this, and I'm just going to say console log names, I'm going to get lots of weird errors because I took out a bunch of other things. I should see, I don't see anything. Oh yeah, that's what I do. I'm going to see this array of all of I have an array of all the names that people suggested, and there's some other errors. So now what I need to do is I need to do this. So this n-grams, remember this n-grams variable stores the table of everything. So what I need to do is instead of having one piece of text that I feed into the model, the n-gram table, the Markov model table thing, let's call it, I need to do that through a loop. So what I need to do is I need to put an outer loop. So I'm going to say for var j equals 0, j is less than names.length, j plus plus. And I'm going to put a loop around all of this. And then what I'm going to do is, this inner loop is the thing that adds stuff to the N-Grams model. What I'm going to do is say var text equals names index I. So I'm going to add each line from that text file one at a time to the model. The reason why I want to do this is I want all of that to be part of the possibilities. However, one thing that's not built into my code is, well, how does a name begin? A name could begin with COD, JOY, COD, THE, ODE, WON. So I want to keep a separate list of actual possible beginnings for the generation process. So on the one hand, I'm kind of done here. Like the thing that won't work, let me run this. Cannot read property length of undefined, sketch.js line 17. Let's see what the error is. Oh, names index J. Boy, that's bad. And J++. So remember, the outer loop is J, so I'm looking at each. There is no I. So that worked. And you can see I'm getting a nice big list with all the sort of possibilities. That table is working. If I hit generate, though, I'm going to have an error. And that error is txt is not defined. Because how I started the generator was with just the first 3 letters, or whatever the order is, of that seed phrase. Now what I think that would make sense to do is I want to create, I'm going to call it beginnings. I don't know if I've mentioned this, by the way, that all the code that I'm writing is based on Python code written by Alison Parrish, and I'll make sure to credit her in both the previous video and this one. I guess I'm mentioning it now. I should have mentioned it in the first one. So thank you, Alison, for that code that at some point I looked at a couple of years ago when I first started doing this stuff. Okay, so that was implanted in my head 2 years ago, and it's coming out right now, I guess. There might be some differences. Never mind. Okay, so what I want to do is have an array called beginnings, which are what are the possible beginnings. So each time I look at a name, the first gram is a possible beginning. So if I equals 0, beginnings dot push gram. So I want to keep track of an extra list of all the possible beginnings. Meaning, here is the table of all of the n-grams and possible outcomes. And if I look at beginnings, here is an array of all of the possible ways that a name could begin. And again, there's redundancy here. And why are they all 2 characters instead of 3? Oh, my n must be 2. The n is 2. OK, that's right. I was going to start with 3. So if I do this again and hit beginnings, we can see, yeah. So these are all the possible ways that a name could begin. And there's redundancy in there. But I like that, because I want my names to begin with the same probabilities as my input data. So now what I'm going to do is down here, the current gram I just need to pick a random beginning. So random beginnings. So I just pick a random beginning, and that's where I start. And then I let the algorithm just go. So let's run it and see what I get. Coding codes and unicolors. Coding time, rainbows, Schiffman's rainbow coding, Haradi's and disk spectrum of colored orange, yellow code, Kitcheon, that in that. Code. So you can see, have we found something yet? I think, first of all, a couple things. One is I should probably limit the name to about maybe 15 characters. I don't know, maybe let's limit it to 20. And maybe let's make the order 2, because it's making too much sense. Coding blander siande. Unicoding happy recodai. Coding pitchy code cod. The kiader drogame. Coding ing happy erden. Ode thatyan rating C. So you can see here that this is working, but what the order is really going to affect the sort of the this.show. Coding balloon, coding meteorological P, happy jumpy dancy codes and. So that order might be too high. I might only be getting the sort of literal names. And another thing here to point out is this would be much more probably interesting if I had a data set of 100,000 names that I could use. Something you might try is to, what's your input data? Come up with what the thing you're trying to name, see if you can find a really big data set. Maybe have a slider where you can adjust the order, so the user can actually pick what that order is as the user is generating text from it. So I don't know if we've come up. I really thought that at the end of this video I'd be able to do this. And now the new name of this channel is let's just say it's, okay, hold on. Let's make the order 3. That's kind of in between. Let's just say it's for the rest of today, the name of this channel is, drum roll, Joy of Light Appearing D. Hashtag Joy of Light Appearing D. See you all in another video. I have some more stuff that I need to talk about, which is looking at generating Markov chains for longer pieces of text, perhaps, as well as on the word level, I think would be worth taking a look at as well. Okay. All right, people in the chat are telling me to update the list. All right, we're going to have to take out some not family friendly. Suggestions. Oh, I think I got most of these already. I'm a little worried about what that might generate. Nervous coding works for me. I can add a few more names in. And let's see what we get. Space of Code Kitchen. Did somebody, space of, that just came out of nowhere. That's the magic of doing this. What did I want to do here? I wanted to change the order again to 2. Haramarin Bowerland Arcs. Lifedan.plastid. Okay, so you get the idea. I'll play with this on my own later. The D is always appearing. Okay, so joy of coding it is once again. Okay, so I think that I am closing in on, let me think. So I think I should look at doing this on the word level. Let me look at my existing examples. So give me a second here. As always, I always forget the this dot, this dot, this dot, this dot. Here, I have an idea. I'm going to play this song just for a little bit. Joy of coding. Joy of coding. Yeah, see? That's a new version of the song. It works. Okay. Okay, so now what I'm looking for is I want to just look at my existing examples. Whoops. Run on a different port. Markov. Okay, so I think that I have successfully kind of talked through this example. I love how much you guys love the This Dot song. I need some more. Who out there wants to make some music and remixes of things? I'll do anything. Okay. What am I looking for here? Okay, so yeah. So these are all good things to look at. The by word thing. Maybe I should at least do a part 3, which does this by word. Let me look at my code and see what the difference is. I think this is going to be pretty easy to do. Oops, no, I want to keep that running. Okay, Markov by word. So this is code that I've written before, and what I do is just do it with an array of tokens. I don't feel like doing this now. I think I'll come back to doing the, I think I will come back to, I think I will come back to this stuff later. I'm going to do a wrap-up video and show some other examples. So let me do a wrap-up week 6 and talk about homework ideas. Oh, I didn't update. I'm going to have to go to my old site. Hold on, everyone. Week 7, Markov Chains. So these are some exercise ideas. Oh, yes, of course. I can't believe I didn't think of that. Okay, so I didn't even mention that in class today. Okay, so I think I'm wrapping up now. I'm going to be here for about 10 more minutes. And I am going to kind of do a wrap-up video to show a few more examples. And close this. And to do a few more examples and talk about some homework exercise ideas. Sorry, I've lost my I've lost my train of thought. Okay, so this is going to be the last video of today. I will be once again live streaming next Tuesday around the same time in the afternoon. And I know that some of you are asking me to update my list. I'm going to run this a lot more later to see if I get anything good. And I'll publish the code and you guys can run it as well. And maybe what I'll do is actually hook it into the spreadsheet when I publish the code so that people can play around with it to see if they come up with any names or hook in their own spreadsheet. Okay, so I'm going to do a wrap-up video to talk about exercises that you could think about doing if you happen to be following this as like a course, which you may or may not be doing. And then I will be gone for the day. I will say, however, that I'm actually going to do a little bit more recording. It just won't be live streamed. As some of you know, I posted an interview with Claire Kearney-Volpe and Chancey Fleet about accessibility in coding. So I'm working on more guest interviews and guest tutorials, and I'm hoping to get another one done this afternoon. So there will be another video with a surprise guest that I will be publishing as well soon. Okay, so here we go. Thank you guys for tuning in. I'll take a few questions after I do this last programming from A to Z wrap-up of week 5 video. Week 7, session 6, whatever it is. Okay. Okay, so maybe you've watched my videos so far about N-Grams and Markov chains and that sort of thing, and you're thinking, what's the next step for you? What could you possibly make? So on the one hand, I think the assignment or the exercise for this week, it's really legitimate to not program anything new. In fact, a lot of using a Markov chain to generate text is about 2 things outside of the actual algorithm itself. Number 1, it's what source text are you picking and why are you picking that source text? And number 2 is what are you presenting to a reader, a viewer, a user, an audience, and what medium are you presenting it in? Are you using a Markov chain to generate dialogue for a performance? Are you using a Markov chain to generate tweets? Are you recreating, news articles and the project about designing a news-like website that looks like real news, but actually it's Markov-generated news? There are a lot of possibilities there. Using a Markov chain to generate text is not really a novel idea at all, and you'll see I'll try to link in this video's description to lots of existing projects that use this technique that you can also find for experimentation. Now, here's the thing though, I have some additional examples that, the videos that I made that if you watched the Markov chain video previously, I'm just implementing the sort of raw algorithm and doing this kind of simple, not simple, but doing this sort of basic implementation of it. So one thing I want to do, and that's this example that's trying to generate coderful Codenbows. That's kind of awesome. Fifth-Mance Raying Schiff. So you can see there's some new names that I'm trying to think of for this channel. Now, I do have some pre-made examples that if you go to the link to the A to Z GitHub repository, you'll see. So I want to highlight some of these. Number 1, and these are, by the way, this is a Markov chain example that does something much like my YouTube channel naming, and it just takes names of lots of media art programs and creates names. So let's see if we get anything good. Cently program in arts and media, arts and code. Media arts pro-graded technologies program. Creations in entrepreneurship, anti-disciplinative technology program, set technology people. So you can see computer action, that's pretty great. So you can see this is the kind of thing for naming. You can also look at my second example and try to find the differences, right, between generating short text. This reads Mary Shelley's Frankenstein from Project Gutenberg and generates kind of an actual very, very long text with paragraphs and everything written in the quote-unquote style, which isn't exactly accurate, but uses a Markov chain to generate a new text. So you might look at those and look at the difference between short text and long text. Both of those examples are generating text on the character by character basis. So when I say a trigram, I mean a collection of a contiguous sequence of 3 characters and 3 characters. But you can also do this by word. So you can consider the tokens not as individual characters but as words. A rainbow is a meteorological. So this is an example that instead of using sequences of characters, using sequences of words, and you can see the result here in a primary rainbow with inverse order of its colors reversed. So at some point, I could go back and do another coding challenge to implement it by word if people are interested in that. But right now, I might just refer you to this code example. Another thing you might think about is what are other tokens or things that happen in sequence in text? For example, this text is not just this sequence of characters or this sequence of words. It's actually a sequence of parts of speech. Verb, noun, verb, determinant, adjective, adverb. I'm getting that in the wrong order. But what this actually does is evaluate the contiguous sequence of parts of speech, use a Markov chain to generate a sequence of parts of speech, and then pick words that are parts of that parts of speech to generate the text. And the result here you can see is the observer. It reaches the meteorological set. The raised section in a section and 40 to 42 degrees % or more in the system between an arc and 50%, et cetera, et cetera. So you can take a look at that example as well. Another thing you might think about is mixing 2 texts within a Markov chain, right? What if I generate, if I take this slider all the way over here, this is generating text using a Markov chain only from Midsummer Night's Dream. This is now generating text only from my Nature of Code book. And now if I kind of put it like over here, let's see if we can generate something good. That's a little bit too Shakespearean. Let's give it a little more Nature of Code. Do it again. Unto his point numbers, rather, voice versions when program, how do I knowledge about that? We add 1. We can be the mouse location, strong prevailment of the true for both x's, and dispose of 0, 0. We still of this kind, wanting, but how to my concide of length 1, then have our motion the close to your youth to 1. Okay, anyway, I got a little too caught up in pretending I'm acting Shakespeare with my Markov chain. But anyway, so you can see that's something you might think about. What if you're mixing 2 texts, 3 texts? How do you adjust the probabilities? I'll give you a little hint. Behind the scenes, if I want the probability of the Shakespeare text to be higher, I just feed the Shakespeare text in multiple times. Again, it's not the most efficient way of doing this, but it works. You can think about other ways that you might do that. You can use a Google Sheet. I have a Mad Libs generator that pulls data from a Google Sheet. You could do the same thing with a Markov chain. You could pull from an API. I have an example that pulls from Reddit. And then also I should mention, of course, that even though I'm using my own Markov generating code based on code written in Python by Alison Parrish, you could also use the Rita library, which has a Markov generator built into it. And I have a previous video that I should link to in this description all about the Rita library and encourage you to look at that and see its implementation. These are things that you could think about. I made a little list here also that I'll reference. So on the one hand, just generate what's your own existing text. What's the order you're picking? How are you presenting it? You could think about just sort of visualizing the frequencies or the possible pathways. This web trigrams by Chris Harrison is a project I referenced. You can see this visualization of those N-Grams is something you might think about. And then I talked about mashing up 2 texts. The Gnoetry project is another useful reference that I'll have a link to. And then the other thing that I think is really important to mention is even though this course and this set of videos I'm focusing on this idea of text, and the characters are words being states, and this continuous sequence of states, this Markov chain, the units of the Markov chain don't have to be text. What if they are musical notes, or rhythms or colors or vectors? What other types of visual designs or sounds or music could you generate through a Markov chain? So I hope you will think about making something with this. You can share it with me at Schiffman on Twitter. You can share it in the comments here. And you can also, if you feel so inclined, support the channel through Patreon. That's if you want to make a financial contribution. And then you can also share and get feedback through a Slack channel that is for Patreon subscribers. Okay, so come back here. Hello. Okay, so can you all see me okay? Sorry, I'm having trouble seeing the chat. Okay, I am back. You should be hearing me in both channels now. That's a Wirecast glitch that I have to change a setting, and it will never save that setting no matter what I do. Okay, so let's see if I can get through now. Please help me in the chat. What was the last thing I said before I froze? I heard maybe I mentioned the Gnoetry project. Did I not talk about how you could use a Markov chain with musical notes or pixel colors? Thank you for watching. Oh, I did say that? Did I get that far? Okay, hold on a second. I don't know why I'm asking, because I have a recording. I will look at my recording. Let me look at the recording. Because if I got all the way to thank you for watching, then I'm good. Generating code based on code written in Python by Alison Parrish. Wait, hold on. You could also use. It's very hard to get to the end here. Markov chains don't have to be text. What if they are musical notes, or rhythms, or colors, or vectors? What other types of visual designs, or sounds, or music could you generate through a Markov chain? So I hope you will think about making something with this. You can share it with me at Schiffman on Twitter. You can share it in the comments here. And you can also, if you feel so inclined, support the channel through Patreon. That's if you want to make a financial contribution. And then you can also share and get feedback through a Slack channel that is for... Sorry, I'm watching myself. Okay, so you can't see it though. Okay, so like it's just like a weird, awkward cutoff. But I did get everything, and the camera shut off. So I'm just gonna like record me saying the last thing about Patreon and Slack, and if Mathieu will figure out what makes sense, how to edit it together. Welcome to people of all ages and from all parts of the world. It's so exciting and nice to see you guys. Okay, so I am going to do that now, and then I'll take a few questions, and then I have to run. But I'm hoping to record more. Let me actually check my... Let me just do that now before I forget, okay? So, what was I saying? I was something about the Slack. Oh. And if you feel so inclined, you can subscribe to the Patreon, link in this video's description. And with subscribing to the Patreon, which is a financial contribution, it's like I hate doing the plugging the Patreon thing. And now I just like feel so awkward doing a special thing just for that. So, but I'm just going to do it anyway. I really could just record thank you for watching, which I think is all that end of that video needed. So, by the way, I heard when I played it back, I heard a little bit of clipping, like the audio buzzes when I speak kind of loudly. I don't know if you guys are noticing that. Okay. You can also subscribe to this channel's Patreon. There's a link in the video's description if you would like to make a financial contribution. Of course, that's optional, but with that, you can get membership to a Slack channel where you can also share your assignments and get feedback from a community of folks in the Slack channel. So thank you so much for watching. I look forward to seeing what you make from this and look forward to seeing you. I don't actually see anybody when I'm doing this. I'm just staring at a camera, but it feels like I am. So I look forward to seeing you in the next video. Okay, bye-bye. Okay, great. So I think I'm done for today. I'll answer a few questions in the chat. Emily McCauley asked, do you know any C languages, not languages written in C? Tongue, emoji. I don't know how exactly to answer this, but I do have some experience programming in C++ and in just plain vanilla old-fashioned C programming. And I used to do a lot of that, I would say, prior to 2005, when things like processing weren't around, frankly. One thing I would say, and I mentioned this before, but for those of you who are interested in C++ and kind of creative applications using C++, I would take a look at Open Frameworks as well as Cinder, which are two creative coding frameworks. There's a question that says, I heard Markov chains are used in neural networks. How does it work? Backing away slowly as the question with the neural network comes up. Oh boy, I'm really planning to make some videos about neural networks. It's going to happen soon, hopefully before the end of the year and more in the spring. One thing I'll say is that there are a lot of sort of text generation experiments and things happening these days. There was a movie script that was written through text generation. And so I think in the same way that you can train the Markov chain to analyze an existing body of text and look at the sequence and probabilities to generate new text, there are ways to do the same with a neural network, in that you can feed a neural network text. The neural network can try to create some type of model of the qualities of that text and generate new text out of that model. So this is something that I do hope to explore in a future video. How's that for I'm like a politician not answering the question? What are all the programming languages you know? C, C++, Java, JavaScript. That's it, I think. Can you do a coding challenge for an incremental clicker? I don't even know what that is, but I would be glad to do so. So people are asking in the chat, just to remind you, if you want email notifications for when I do a live stream, codingrainbow.com. Please, if you feel so inclined, subscribe to the channel and watch the videos. That's actually one of the things that you can do. If people have also asked if they could contribute, and I'm always looking for people to subtitle or translate the videos to help make them more accessible. So if you're interested in helping with that, please reach out to me. It's pretty easy to do. You can do it directly on YouTube. Oh, I know PHP. Yeah, I know PHP. No, I don't really do Ruby, Python, or Lua, but I'm interested in all those languages. Python's awesome, right? Can you still buy stickers? Yeah, those stickers are still for sale. I still have a lot of them. I don't know if at some point I'm going to have to take that down, but get them now if you want the stickers. Chatbot could be a subject related to this. Yes, something I'm really interested in doing, by the way. I just got one of those Amazon Echo things, and I'm interested in doing some kind of text-to-speech. I wanted to do a video about how to make a skill for the Amazon Alexa, and I was going to make a Harry Potter sorting hat based on a Twitter bot that Darius Kazemi made called the Sorting Bot. Super Collider. A little bit of Arduino experience. I hope to have some guests do some physical computing videos on this channel at some point. I'm having guests do topics that I'm not as experienced with, like 3D and Arduino and that type of thing. I guess I know HTML, CSS, if those are programming languages. We could have a discussion. How long have I been learning to program? Well, I like the way you asked that question, because I'm still learning to program. I'll always be learning to program. There's no, JavaScript, by the way, I never programmed in until like a year and a half ago or 2 years ago. I can't remember now at this point. But I really didn't program seriously until, I don't know if seriously is the right word, but I didn't really program until 2001. I had done a few classes in middle school and in high school and in college, but I had never really taken to it or made anything with it until I started as a student at ITP, that program where I teach now. A tutorial on how to make a GUI interface in C#. Okay. A video about hamming distance. Boy, there are all these suggestions of things that how do I see JavaScript in 10 years? It won't exist anymore? I don't know. I don't know. I don't like to predict the future. I like to just enjoy the stuff that that's happening now and that I can kind of play with. Is there a web-based P5 IDE? There is one in development. It's very far along. We are alpha testing it at ITP. Unfortunately, we're just not ready to have sort of like a large number of people using it, but I would expect it to come in early 2017. Our goal is to have it out for the spring semester. Yes, I want to do steering stuff with neural networks, and reinforcement learning is something that I'm really hoping to be able to tackle. I don't know how to do it, so I have to figure it out. I've been reading and researching. Browser automation. I am going to do Chrome extensions at some point this fall. Okay, so you guys are giving me a lot of great suggestions. I am going to play my goodbye music. When this song ends, I will cut off the stream. I'll do some like... Always with the rainbows. If you have suggestions for a channel name, I'm all ears right now. Thinking about Joy of Coding. I need some new design stuff. Scott Wooden, who did all of the logo and website design, hopefully he might be available to continue to do that work. But if anybody wants to contribute or has ideas, I'm welcome. Would love to hear. Hello, Ireland. Hello, Coding Proism. Yes, I like Coding Rainbow as well. Coding Prism, maybe is what you meant. Welcome, new listeners, viewers. I will be back next Tuesday afternoon, somewhere around the same time, probably in the 1:30 to 4 o'clock Eastern Standard Time hour. Harry Potter invisibility with that shirt. That's a great idea. And we'll see what we'll do. That's that. Rainbows and unicorns, may you find them in your life, in your week. Hope you spend some time outside with friends, with people, not programming, or programming with people. I was outside walking in the park in New York City. The leaves were changing. It was beautiful. There were ducks. And I have to say, as much as I enjoyed writing a Markov chain, I enjoyed the ducks and the leaves almost just as much. Hello to Berlin. I am a unicorn. Today's stream was about Markov chains. If you missed it, the archive of this live stream will make its way onto YouTube at some point soon, as well as edited versions of the videos today. Fun Function is a great other YouTube channel. And here we go. I've got about, I don't know how much longer this song has. A minute left. Hello, New Zealand. I've never been to New Zealand, and I would love to go there. Coding Unchained. Thank you for the stream. You're welcome. Deca Codatron. Nepal. That's wonderful. Hello, Nepal. This is part of the live stream where I just say hello to various countries. Brazil, India. And I will see you guys next week. What else? Context-free grammars. Make some stuff. Share it with me. I really, somebody remind me on Monday to gather on the Slack channel or over Twitter things that people have made. Twitter bots, word counting, and Markov chain stuff, so I can show a few viewer-created projects on the live stream next week. Okay? Hello, Belfast. Hello, US and Mexico City in the Netherlands. And I'm signing out from SFPC in the West Village, and I'll see you all soon.